Good morning, good afternoon to everyone, and welcome to our developer coaching event. My name is Violeta and will be one of your hosts for this session. Today, we will talk about AI and open source services, and we have Irine, Luigi, and Piotr here with us, and they have built very interesting use case to showcase. And of course, you can use this opportunity to learn from our colleagues. Irene, Luigi, Piotr, would you like to say hello?
Hi everyone, I'm Irene and I'm part of the open source data specialist team.
Hello everyone, I'm Luigi and I'm part of the OCI Generative AI specialist team.
Hi everyone, I'm glad to have you all here. My name is Piotr Kurzynoga and I'm also part of the EMEA open source specialist team together with Irine.
Thank you. Okay, so for today, we offer the possibility to get more on the Oracle cloud credits by providing this Oracle free tier promo code for everybody attending the call, which consists in $500 that you can use for a 30 days period time to test our services, of course. You will get the promo link within the follow-up email, as I said, together with the recording. This will come this Friday. What it is important to keep in mind here is that you have to use the same email address that you used to register for this call when you do the sign-in process. Otherwise, of course, it will not work. In case you will not see the promo banner after you end the sign-up process, then feel free to reach out to us on Slack, and we will help you. And all the examples and data presented in the following demos are purely fictive and for showcasing purposes only. So keep that in mind. And also regarding the scope of this session, keep in mind that this is purely educational. If you are planning to using our services further, feel free to connect with your account team. With that, I would like to hand it over to Piotr now. Piotr, over to you.
Thank you very much, Violeta. Once again, thank you all for coming to this developer coaching event. We will be covering a demo airport use case of a chatbot with OCI open source managed services as well as OCI AI services. So this is the standard safe harbor statement. But after that, I would like to take you over to the agenda of today's meeting. So as already mentioned, the main part of this session is the demo itself, where we will show you step by step how all of the different elements of the architecture interact with each other. But before we do that, we will dive into the detailed architecture itself. We'll briefly talk about the data structure and how we translate it in between the different steps of the pipeline. Then Luigi will take you over the artificial intelligence bit, the natural language to SQL part, and how that works with the OCI PostgreSQL database in this case. Later on, Irene will talk about usage capabilities, right, in terms of this demo, what it is capable of, what enhancements could there possibly be added to it, as well as other use cases and practical applications of generative AI with PostgreSQL on OCI. So without further ado, let me get into the solution architecture and how it's actually made. So starting off, we have an airport. That is the use case, right? So imagine we have an incoming stream of data with passenger information, with luggage information, various flights, and everything else you can imagine around airport operations. Now, while we're not directly connected to an airport in this particular case, we are faking it, let's say, with a CSV stream, which is then sent to a Kafka producer, right? And with that, it is sent to OCI or Oracle Cloud Infrastructure. And that is where it lands in OCI Streaming. So that is our entry point to OCI. Once we have it in the cloud, we are then processing the data using Apache Spark. And to be precise, we are using OCI Data Flow, which is our managed service for Apache Spark here. And it allows us to perform various operations on the data, consume the actual stream from OCI Streaming. And as well, we can perform various operations such as enriching the data from other sources. In this case, that is the autonomous database, right? The key point here is that we can connect various sinks. We can connect various other sources where we consume the data, enrich it, perform data engineering, and then ultimately save it to one or more data sources. So that is where the power and the scalability and the ability for data flow to process petabyte scale volumes of data comes from. And as well, we can enhance that with other machine learning strategies, as OCI Data Flow does support GPU shapes. So once we perform the data enriching, data filtering, and separate our data model into the target data model as it is in OCI PostgreSQL, that is precisely where we save it. So then the text-to-SQL agent can fetch the data from the database, perform all the natural language to SQL conversion, and ultimately expose that via a chat interface to our to the person that is traveling, right? And for example, wants to ask, hey, how many passengers are on this flight, as an example, right? So that is the basis of this architecture, and that is what we will be taking you through today. And with that, I will pass it over to Irene, and she will talk to you about the data structure itself.
Thank you, Piotr. So now let's look at the data structure and see how we can transform flat data into relational tables. So in this flowchart, first we have our flat CSV input data, and this is just a sample data set stored in OCI object storage. So this data requires processing before it can be stored in as a relational database. Next, we have our Kafka producer, which picks up this raw data, converts it into a JSON format, and then publishes it into Kafka topic in OCI Streaming. So OCI Streaming ensures the smooth transfer of this JSON data in real time, allowing for high speed and low latency processing. So once we have our data streamed, the data reaches OCI Data Flow, and this acts as a consumer where it is further processed. And we also enrich the data using Oracle Autonomous Database, where we add important passenger details before final storage. So finally, we store the structured data in Postgres across 3 different tables, namely the luggage table, the flight table, and the persons table. So this is the relational data model for Postgres, which structures the data into 3 entities, like I mentioned before: person, luggage, and flight. So this ensures that all of the data is well organized and easily accessible. So the first table on the left is the persons table, and this stores passenger details such as the first name, last name, nationality, and also the flight information. And it helps us to link the passengers both to their luggage and also to their respective flights. So next we have the luggage table, which tracks baggage details. And this contains the luggage ID, the status, timestamp, and this is also linked back to the passenger and also their flight. And lastly, we have our flight table, and this holds flight-specific details like the inbound destination and the outbound destination. It helps us track timestamps and also the flight status. So from this, you can see that there's a clear relationship between all of these tables, where a single passenger could have multiple luggages, a single flight could have multiple passengers, and multiple pieces of luggage can be associated to a single flight. So now let's look at the end user experience of our airport chatbot. Here you can see this is how the UI of the chatbot looks like, and it allows users to interact with our database in a very natural and intuitive way. So first, users can ask questions in a natural language, eliminating the need to write SQL manually. And next, the chatbot fetches the data directly from the relational database without any embedding or vector-based search. So this can make the process of querying way faster and more efficient. So during the live demo, Luigi will show you the chatbot, and we can see that there are a few preset questions that are available, allowing us for quicker interactions with frequently asked queries. And additionally, there's a feature for showing SQL, which allows users to preview the SQL query that was generated based on their input. So now let me pass it on to Piotr to walk us through the live demo.
Thank you very much, Irine. Let me start sharing my screen, and I will guide you through the steps of the demo itself. So before, let's see if this is sharing. Okay. So before we can actually start using the chatbot, before we can start retrieving the information, that data has to pass all the way from the said airport, right, to the database where we can then fetch it from. So where we start is we start with a data flow pool. A data flow pool allows us to quickly spin up our applications quicker, and thus allows us for quick processing, quick shutdown, and also prevents us of wasting resources, right? So you can see there is something like an idle timeout. So if the applications are stopped or are not performing any actions, ultimately the pool would shut down, therefore also saving you costs. So this is a great feature to keep in mind of. So that is our airport pool. Now let's see inside of our airport pool, we have two separate applications. One is airport streaming, as you can see here, and the other one is airport information processing. So what the airport streaming is responsible for here is the actual CSV to Kafka conversion. So what we do is we have a directory where we have CSV files sitting, and those CSV files are ingested by Data Flow, and then that data is sent to the Kafka producer, and ultimately lands in OCI Streaming. So it is important to note that once again, this can be ultimately any form of data source, and we can easily ingest that into the cloud in this case. So what an additional benefit is the fact that once again, we're working with a directory, right? So we can just keep adding, for example, CSV files into it, so it continues processing them. As this is Spark structured streaming, the application will actually continue working 24/7 non-stop as long as there is incoming data. So that is the huge advantage of that here. And now let me actually take you over to the application itself. So this is the airport streaming, as you can see. That's the application. And if I open the Spark UI, we will be able to see that we are inside of the airport streaming application here in the top right corner, and you can see the jobs being executed. So I am kind of misusing Spark here because you can see these jobs are kind of happening at separate intervals. And if I scroll down, you can see that they're actually being executed around every 2 seconds. So that is an artificial delay I have introduced to simulate basically passengers and flights, let's say, arriving and various airport operations happening in this case. But it gives us a good understanding of what exactly is happening here. So now, if I move on to my actual stream and press load messages, I will be able to see those messages once again taken from that CSV, processed in the application, and then sent to OCI Streaming. If I take a closer look at what this payload looks like, I'm able to see the passenger ID, the baggage ID, the flight ID, and the status of each of the aforementioned passenger, flight, and luggage, as well as the destination of the flight in this particular case. Another thing you can actually see here is the fact, if we look at the timestamp, we can see those 2-second intervals presented right here. So once again, we're getting a good idea of what is happening here. So now, if I move forward to the airport information processing piece itself, that is where we're consuming the data from OCI Streaming, where we're consuming that Kafka stream, and then we're performing the data enriching process and also splitting the data model into those 3 separate tables that you have just seen, the flight, luggage, and passengers ones. What the data enriching does in this particular case is there is a table, right, sitting in the autonomous database, which has the actual passenger names, and it matches those names to the ID that is coming from the stream itself. So we are also limiting the amount of data that is being sent from, let's say, the airport in that case, and we're able to also demonstrate how we can actually enhance an existing stream of data with external data sources. So if I open the Spark UI here, I will be able to see that I'm once again, in this case, in airport processing now. So that is where the processing is happening. And if I go to my structured streaming, you will be able to see 3 separate streaming queries. So we have person processing, luggage processing, and flight processing. So we've went from one single stream of data to 3 separate streams by splitting the data model in this case, and also performing some other filtering and enriching operations. If we were to dive into any of those, for example, luggage processing, right, we would be able to see how many records we're processing and how that actually looks like from a statistics perspective. So that is the flow from the airport until basically data flow, and at this point we're ready to insert into the database itself. So let's take a quick look at what we're actually seeing in the database. So let me have a quick look at the recent messages. So I can see that there currently passenger statuses are being checked in, the flight status is en route, the luggage is loaded onto the aircraft, and we're looking at inbound London Heathrow, so New York to London Heathrow. So let's take a look at the database itself and what we are seeing here. So London Heathrow to New York, if I refresh, precisely here it is, we can see that the flight is en route. And as I'm refreshing the database, essentially, as I'm querying the database, you can see the status of the flights is actually changing, right? And the same for the people. So what Irene has previously mentioned in terms of the relation between the different tables, right? At any point, I can simply navigate from a passenger to set flight, for example, right? Or the luggage that's bound to this passenger itself, right? We can see that this luggage is now loaded onto the aircraft. So that is the flow from, once again, from the airport, going through the streaming, various processing, filtering, and enriching, and then ultimately landing in our OCI PostgreSQL database. So now, let me reshare my PowerPoint and just quickly recap on what we have just seen. So we've went with real-time or near real-time changes in the state of luggage, flight, and passenger. We've injected that data into OCI Streaming, then processed the changes once again, took the passenger information from the autonomous database to enrich that information, split that into the 3 different tables, and ultimately saved it in PostgreSQL. Now, Luigi will show you the second part, which comes with basically the generative AI part and LangChain, where we have the chatbot interface running and where the person traveling is actually able to make the various queries in natural language. Not part of this demo is a part where you could actually enhance this further by storing actual embeddings in the database. These could be various operational instructions around the airport, and what else you can imagine that could help the passengers further in navigating around the airport. For example, like an airport escape plan, or where each particular terminal resides. So with that, I would like to pass it over to Luigi.
Okay, thank you very much, Piotr. Okay, now we will be talking about how to query the data that have been ingested in the Postgres database, and we want to simplify as much as possible the access from the passenger to the data. So the idea is to enable the passengers or the user of this system to use natural language to express what are their needs regarding the data. Next slide, please. First of all, before showing the demo, the chatbot part, I want to clarify some concepts, because probably some concepts are already available to you, some concepts are new to you. When we talk about querying data using natural language, a term that is always used is text-to-SQL. Text-to-SQL means that you make a question in natural language. For example, I want to know the status of all the flights starting from Paris airport. Or another query could be, I want to know what is the status of my luggage, and my name is Luigi Saetta. Okay, well, the data are stored inside a relational database. For this cloud developer coaching session, we have used the Postgres database. And you know that the language that is used to query a relational database since many years is SQL. So what we need to do is to translate the user request in English on whatever language you want. Also the other language, the main languages from Europe and other countries are supported into SQL. This task, translating the request in natural language in SQL, is called text-to-SQL. And what we want to do is to use a large language model, generative AI model, to translate the text into SQL. Obviously, the large language model, and for this demo we have used the model from Meta, the Llama 3.1 model, is able to understand the request. Okay, so that problem is solved. But the language model doesn't know how has been designed the specific database of this demo. So in addition to the user request, we need to add some more information to the large language model. The schema information, the description of the tables that are inside the database. And you have seen from the previous slide, we have 3 tables, flights, luggage, and so on. And also the name of the fields. And also we have to give some more information in order to enable language model to link the request and the kind of request that you want to make with the tables, in order to solve the third point, the mapping between the natural language and the mappings. The large language model so received a prompt with all this information and generate the SQL query. The SQL query is checked against the database. If it is okay, it is executed and the data are shown. Otherwise, it can retry, because sometimes, especially with very complicated schema, the first try could not be the right one. Okay, now I'm going to take the screen because I want to show the actual demo. So let's go here. Okay, we have created on top of the system that we have developed a simple web interface, and you see in the middle we can make the question in natural language, and also to simplify, because sometimes it's not easy to remember all the kind of requests that you can do. We have put some example of requests on the left. But the first thing is probably that one wants to do is to start learning about the data that we have. So the first question in natural language that I want to do is list all the available tables in the DB. Okay. So you can see I've checked on the left also to show the SQL, and as you can see, it has been really fast. Here we have the SQL that has been generated, it has been executed, and it shows the names of the three tables. The tables with information regarding the luggage, the tables with information regarding the passenger, and the tables regarding the flight. And so, for example, if I want to have more information, I can ask, OK, describe me the table's flights. Okay, and you see it has generated another query, and it is gathered, in this case, from the dictionary of the database with the list of all the fields and the description of the data type. So if we want, we can understand also using this tool what is the structure of the schema. For this demo, the schema is not really complicated. We have only 3 tables, but it can work also on more complicated schema. Now, let's try with some real query. So to avoid to waste your time, I will check the second query from the left, and you see what I want is the list of all the flights starting from one of the airport, the Paris Charles de Gaulle airport, and also I want some more details, because behind the scene I want to create a join, so a more complicated kind of query between several tables. So I want information regarding flights, the name of the passenger, and the data regarding the luggages for that flight. In this way, if you remember, we have 3 tables. I can create a join with all the 3 tables. If I run the query, as you can see, we go through the steps. So again, the select statement has been generated and has been shown here. And as you can see, the select statement correctly joins flight, luggage, and person, the table that contains the details of the person. And you can see here all the information that we have got from all the 3 tables. And for example, I can go here and I can say, okay, I want to change. I want the flights starting from Rome airport. Rome has 2 airports. I'm based in Italy, so I'm living in Rome. That's the reason why I'm choosing this other example. So I'm going to specify that I want the Fiumicino airport, that is the biggest one. And I can make another query, and as you can see, we see all the data regarding the flight starting from the airport. So you can see in this way, obviously for this demo, the database is not so complicated, but we can, for example, wait for some minutes and we can run again, and we will see the flow data running through all the architecture that has been showed by Piotr. Now I will give the sharing back to Piotr. Can you show the slides? And we will continue showing the slide. Can you show the slide? Okay, thank you. Now, okay, thank you. Now, we have seen the demo. I want to take some minutes to explain with some more details. First, starting from what is a reference architecture if you want to implement such a solution in a, let's say, a more complicated database. One information, this is a reference architecture that we have published, my team has published, and you can find it in the Oracle architecture site in our public site on internet. In this reference architecture, as you can see, we have several pieces. First of all, in a general system, we have a router. Why we have a router? Because when you do interaction with a generative AI system and want to make questions, probably some questions want to load data from the database, but other question could be of the kind, okay, create a report summarizing all this data. So the router has to decide based on the user request if you want to do generation of SQL or if you want to do another actions, for example, creating the report and so route to the appropriate part of the agent. The part that we are more talking about is the SQL generator. The SQL generator does the text-to-SQL task. Take the request in natural language, list all the flights starting from Fiumicino Airport and generate the SQL. Then the execution is simple because we are using the API of the database, in this case, the Postgres database. In general, the schema can be very complex. For example, we have one demo that runs on 200 tables. So if you want to design a robust enterprise solution, you cannot think to send in one request the information of the entire schema as input to the prompt because it were too big. And so you have to choose part of the schema. And here it is in the middle, a schema manager that provides, based on user request, a restricted schema, only with the list of tables that are candidate to be used for the generation of the SQL query. And the schema manager takes the information, the DDL with description of the tables and the field from the data dictionary or the database, okay? This is the general architecture. In addition, in a production system, you want to gather also information, for example, to see that everything is going fine, that the performance are okay. So you have also to think about the monitoring. And for example, you can add using our part in Oracle Cloud, the application performance monitoring to gather information. For example, what is the average time needed to generate the SQL? What is the average time needed to execute the SQL, and all this kind of information that we publish in a dashboard that you can create again on Oracle Cloud. This is the general architecture. Now, let's see at the physical architecture. In the physical architecture, well, there are different ways to deploy these kind of things. In our implementation, the orchestration of the call to generative AI services, that is the services that provide the Meta Llama 3.1 model and all the other things, well, we can think to have it as code running in a virtual machine in Oracle Cloud, or you can deploy that as a Docker container inside our Kubernetes engine. Okay, for the in the left part, regarding the metadata management, you need to have a database separate from the data database, and in our in a general architecture, you can think to put the metadata inside an Oracle database, or you could use a Postgres database also for the metadata. The cache that you see on the bottom is to maintain the conversational state, to maintain the storage of the message passed back and forth to the user and the system. Next and last slide. Okay, this is the real architecture that we have implemented in this demo. It's simplified because, as I said, we have only 3 tables. With 3 tables, you can send the same schema every time to the large language model. So in the demo, the schema management is actually not really needed because the database is small. But in a larger situation, you will need also to manage the schema leaking. Okay, and so it's all on my side. Thank you.
Hello. Okay, thank you, Luigi, for showing us the live chatbot. And now let's look at the capabilities of our real-time airport chatbot. So passengers can use this chatbot to verify their check-in status and also retrieve real-time flight updates, including potential delays. This chatbot can also be used to help with luggage tracking. So passengers can check whether their luggage has been successfully checked in. They can also check whether their luggage has been damaged or if it's at baggage claim. And also it can be used as an easy lookup for the belt at which the luggage is located. So now let's look at a few possible enhancements for our airport chatbot. So we'll be mainly focusing on the data points that could be added to make it more efficient and insightful for operations, passengers, and also sustainability efforts. So we could integrate real-time and forecasted weather data. It could include temperature, visibility, and wind speed. And this can help with predicting delays and also improve operational planning. So another data point that could be added is layover terminal transfer times. So for example, passengers often need to switch terminals during their layovers. So predicting this terminal transfer time can help with estimating whether a passenger would make their connection on time or not. We can also add live flight tracking, where we track the aircraft position, altitude, and speed. And this can help us better communicate on arrivals, delays, and routing. We can also add historical flight schedules. So for example, let's say a flight is going from UK to US. The same aircraft might be coming from Dubai to UK. So analyzing these past flight schedules can help airlines understand delay patterns, optimize routes, and also enhance operational planning and customer service. And finally, we can add forecasted fuel consumption and emissions to align with sustainability goals. And this allows airlines to track CO2 output and also adhere to regulatory requirements. So now let's look at the practical applications of GenAI with Postgres on OCI. So there are many ways we can use this technology, but here are a few we've picked. So the first one is employee insights and HR automation. So HR teams can instantly retrieve employee data, and this can help them to make informed decisions faster. So for example, let's say an HR rep can ask how many remaining leaves are there for an employee of this ID instead of manually searching records. Next is e-commerce insights, where businesses can analyze customer data and product performance in real time. So for example, they can ask what is the top 5 best-selling products in the last month, and this can help them gain some actionable insights. We can also create an healthcare query assistance, where healthcare providers can efficiently access and analyze patient data. So for example, a doctor or an assistant could ask, show all the appointments for Dr. Smith this week, and this can make scheduling and data retrieval seamless. So these are just a few examples on how GenAI with Postgres on OCI can simplify everyday tasks. But this technology can be applied across various industries. It could be the finance industry, customer support, manufacturing, and logistics. And this can help enable us to make faster, smarter decisions and also help in automation at scale. So finally, we have a few links to examples and documentations. We have a GitHub page for examples for our open source data platform team. And also we have a link for our OCI GenAI reference architecture. And thank you for watching. That's it for our session today. And let me pass it off to Violetta.
Next week, we will talk about database APIs with SQL in Oracle Database 23 AI. We have Chris Saxon, who will present to you a very a cool use case, and I know he has got also some cool demos. So if you'd like to hear more about it and to learn from us, feel free to go to our events page and register. There is also another place you can find information about the upcoming events, and this is the Oracle for Developers official page. You have the links here on this slide and also on chat and Q&A. Also, because we talk about upcoming events, I think it's the perfect moment now to launch the poll, which is asking you what other topics you would like us to cover within the upcoming events. And I would like to give you a couple of minutes to read the topics and vote. You can choose multiple topics, by the way. And then let's just move on with the next slide. So there are a lot of in-person events and also online events that are happening, and the Oracle Cloud World Tour 2025 is now happening. The next event, I know it will be in, and I hope that I'm not wrong, in Madrid. So if you'd like to see real use case scenarios and our specialist presenting a lot of demos and presentation and talking about our technology, then, and if you are, of course, in the cities that we do these events, feel free to register, and we hope to see you there. Here is another page, namely AI Solutions Hub, and I know that Luigi and the team, everybody is contributing to this page with publishing demos, use cases, real world scenarios, the source codes, and many more. Very, very useful page. You have the link on chat. Feel free to save it and check there based on your interest. Let's see if there is anything. Okay, I see, Piotr, you want to make a comment on one of the questions?
That's right. Thank you, Violetta.
Over to you.
No, there is one question regarding the ground staff being able to write back to the passenger information, and if that wasn't clear, that is exactly the purpose of enriching the information with the external source, which in this case was Autonomous Database. So to be more precise, there could be an interface. In this case, it is actually Apex, where you have a report where you could basically edit passenger information or change it. This could be done by airport staff. This could be done by airline staff, right? So this could be exposed via not only one, but multiple applications that have different roles and permissions, and that could all come back to the same, let's say, single source of truth, which in this case would be the OCI PostgreSQL database. I hope that answers your question. Thank you.
Thank you, Piotr. I see that there is no other questions. So with that, I think we will finish a little earlier. I will give some of your time back. Many thanks for being here with us today, team. Many thanks for presenting. We hope to have you back soon at developer coaching events. And for our customers, we hope to see you in the next ones. Enjoy the rest of the afternoon and take care of yourselves. Bye-bye.
Bye. Have a nice day.